Hey YouTube, this is Marcus with another video. Today we're going to be changing a front wheel hub and bearing assembly on the 2006 Ford Taurus. It belongs to my wife. You'll have to excuse me if I occasionally sound a little bit snotty. I think I'm catching a cold or something. You can see here we've got a Moog wheel hub and bearing assembly, and I've already replaced the passenger side one. Today we're doing the one on the driver's side because it's got a bad howl. And since I've already replaced this one, that means it's coming from that side. It's a little bit difficult to tell which side it's coming from sometimes because I'm sitting in the driver's seat, so it kind of still sounds like it's coming from this side, but I've replaced this bearing, so I know it's not this one. And my friend who rode with me the other day in the passenger seat said it sounded like it was coming from this side to him. So the best solution is just go ahead and replace the other wheel bearing and call it a day. But the first thing I need to do is move my transport school bus out of the way. This is just one I use to drive home in. There we go. We'll let that build up air pressure and move the car out of the way because I want to be able to position the car on sort of level ground. And Lord, I need to shave. And I don't want the bus to be trapped in here in the event that I'm not done by tomorrow morning. Alright, so the first thing we need to do is chock the back wheel. Alright, the next order of business is to break loose these lug nuts while it's still sitting on the ground. There we go. Alrighty, now we can lift it. I've got a jack stand here. What I'm going to do, now that the tire is clear of the ground, I'm going to continue to lift the car until the jack stand has a spot where I can lock it that will fit under the car, so that when I lower it, I want to preload some of the weight onto this jack stand and still have the tire suspended, because you never want to have just your jack holding up your car. You always want to have 2 points of contact, so that if the jack kicks sideways or just straight up fails, there's something else here to catch the vehicle before it lands on you. Jack stand is good, jack is good, and tire's still off the ground. See, here's what I was talking about. I didn't necessarily lower the jack, the weight of the vehicle, completely onto the jack stand, but I did what you call preload it, where you back it down enough that some of the weight has locked this into position, because just having the jack stand under here isn't necessarily the safest thing. If there's a gap and this fails and the car has to fall any distance and smack into the top of the jack stand, there's a chance that the jack stand could also fail from that sudden smacking impact and kick sideways or something. So you want to preload your jack stand a little bit so that it's locked into place, and so now we have 2 points of contact, so that if this one fails, this one will catch it. Alright, so our next step is to go ahead and finish backing off the lug nuts. There's the lug nuts. Now at this point, if you haven't had your wheel off in a long time, it might be stuck. It may not want to come off. That's normal. What will happen is sometimes they'll actually rust between the rotor and the hub and the wheel. They'll rust right here in the center. So just kick it a time or two on the outside edge and it'll pop loose. We're going to pull the tire off, use it as a chair. Alright, so the next thing we need to remove is the caliper, but the caliper comes in two parts. You've got the caliper and the bracket. We're not worried about the caliper itself, we just need the whole assembly off here. So what we're going to do, if you come in the back here, you've got two different sets of bolts. You've got these, which hold the caliper to the bracket. We're not worried about those. If you look on back here, you'll find a second set. There's one on top and one down toward the bottom. These are about 15 millimeters or a 5/8. Both of those wrenches fit, and the next size down that I have won't fit, so a 14 millimeter doesn't quite fit, but a 15 millimeter has a little bit of play. But it does grab it enough that I'm pretty sure we can get it off here without stripping it or causing any problems. So we'll take our 15 millimeter. Now you have to think about these bolts as they're put in. So on this side, you got to think the bolts are coming in from this direction. They're not threaded backwards. So righty-tighty, lefty-loosey. but in reference to the bolt coming from this direction. So for us, it would be to our right to loosen it, because that's to the bolt's left. And we'll just... There we go. Alrighty, that one's loose. Let's go ahead and loosen the other one. We have... This is the bottom one for the caliper. That's not what we want. What we want is this one. That's the bottom one for the bracket here that the caliper bolts into. So if we take out these two bolts, the whole caliper, bracket and all, will lift off of here. The reason we need the whole assembly is because the bracket that the caliper attaches to is this. And if we leave this attached, even if we remove the spindle nut, the rotor and everything won't come off, because this is bolted to the back plate and sort of cups around it like this and won't let it come off. So we have to remove the caliper and the bracket together. Alrighty, so same deal here. I'm actually kind of using you guys as a mirror. We lock our 15mm wrench on it, and it's now, because the wrench is angled downward, we need to bang it to our left this way, because you got to think the bolt came in this direction, so it needs to turn like this to loosen. So we'll give it some motivation here with some light taps. There it goes. One of the reasons these are so tight, if I remember correctly, they've got yellow Loctite on them. And so we're breaking that yellow Loctite. Yep, see that right there? There's yellow Loctite there on the threads. So that's why they were so hard to get out. Now, one thing we've got on hand here that you may want to keep available is a bungee cord, a piece of 550 cord, anything like that. Because whenever this caliper pops loose, you don't want to let it fall on the brake line. You want to tie it up to your strut or something up here so that the weight of the whole caliper doesn't yank on that brake line. Because if you look here, here's your brake fluid line. That's rubber. And as long as it's been here, if you let this fall and yank on that or just hang on it, there's a chance it could crack and bust your brake line. So once this comes loose, I'm just going to tie some 550 cord through the top of the bracket here and tie it up to the strut or something so that there's no weight pulling down on this rubber brake line. There's our other bolt. Now if it is stuck onto the rotor a little bit, which on this one it's freely moving, we just gotta, you can just take a pry bar or something, wedge down in between them here and just lift a little. There we go. And we're going to take our caliper and just sort of tie it up out of the way here for the time being. Now here's another step where your rotor might be stuck back like this and you can't get the rotor loose. The same kind of thing happens here. It's bad to rust right here where these two surfaces mate together. Just take a hammer and lightly tap around the inside here, maybe kick the outside edge with your foot, something like that, and it'll pop loose. So for mine, because I've recently had it off to put new brake pads on it, it'll just slide off. We'll lay that over here. So now we have access to the hub and bearing assembly. The next step is to back off this spindle nut. To do so, we need, I believe this is the one for the car, a 29mm socket. Now I'm going to be using this with my 1/2-inch breaker bar because I do not want to put the amount of torque that we're going to need to get this off on my ratchet. So we'll go ahead and get set up here. Alright, now this part is going to be extremely difficult. Alright, because there's a lot of torque applied to this. You may even need an extension to slip over the end of your breaker bar here to break this loose. But I'm going to try it barehanded first and see how far I get. Alright, let's try flipping it over. It just needed the proper motivation. There it comes. Alright, so we still got a little bit left. Yeah, that's hot. That friction. Now, here's a little piece of information. Double check the part you get, because you may have to keep your nut and the washer, because this is a Moog hub and bearing assembly, but as you can see, it did not come with its own nut and washer, so we're going to have to reuse our old ones. So, double check that before you go throwing these old ones away. Alrighty. There's our old nut. There's the old washer. That had Loctite on it too. Now here's where things get a little bit interesting. So here's where things differ from the pickup truck, where the pickup truck was rear wheel drive. The front hub and bearing assemblies just had a smooth spindle that they slid over top of and free spun. You greased that as you put it on, you were good. This is a front wheel drive, so your front hub and bearing assembly has to be fixed into position so that the back plate of it stays steady and the axle can apply rotational force to the wheels independent of the back plate. So what we have here is we have 1, 2, 3 bolts here that come in from the back side here to hold the back plate. Here on the new one, you've got this triangular back plate, and you've got those 3 bolts that hold that steady, and the axle is actually splined into the hub and bearing assembly. So we need to do a couple of things here. I need to get my wood maul and tap the end of the axle to free it from the hub and bearing assembly. It's not going to come completely out because it doesn't have that much backwards travel, but I want to at least break it loose. And then we need to get those 3 bolts out of the back plate, and then the real fun starts. I'm going to thread this back on here because I don't want to flatten out the end of the axle. There we go, it's loose. Now here's part of the reason that I wanted to put the jack under here to begin with, because 2 of the bolts are on the bottom. They're fine. The top bolt, however, is back. I don't know if I can get you guys in here. The top bolt is right there, and you see how the CV axle is canted at an angle? We're going to have to lift the whole assembly here to straighten that out so we can get a socket back in there to take that bolt out. But we'll get the bottom 2 first. There we go. Movement there. Now the same thing is true here. They've got Loctite on these, so they're going to be a bear to get off until you get them going. Alright, so we're getting to a point now where the bolt's nearly out, and it's getting hard to keep the socket on there because of the axle. So what I'm going to do, since I've already loosened the axle, you may have to tap it a time or 2 to break it back loose. I'm just going to take my hand and I'm going to press on it and get my socket seated back on there properly. Alright, it's pretty well out now. I should be able to. There's that one. Now these have blue Loctite. There it comes. Now one thing you want to watch for when you're doing bolts like these, any kind of bolt like this where you've got a long bolt connecting multiple metal parts, a lot of friction will build up between these parts, and it is easier than you think to twist these bolts in 2. So when you're loosening a bolt like this that's really tight, if you can see the other side of it, watch for movement on the other side of it, because if this moves and this doesn't, you're twisting your bolt in two. And once you twist it in two, maybe with something like this you might be able to just drill it out and put a bigger bolt through it with a nut or something, but that's something you really want to avoid. That's one reason that I kind of tap mine with a hammer instead of just applying all of my force all at one time, because if there's rust and corrosion here holding these threads still, that's an easy way to twist them in two. Alright, so here's what I was talking about earlier. You can see we got a 5/8 here, but we can't quite get it back in here. So we need to lift this until it's relatively straight. So since we have the jack stand here, the tools up under here, we should be able to just completely lower the jack onto the jack stand. Alrighty, so what I'm going to attempt to do here is right there, right behind the lower ball joint, not on the lower ball joint, just right behind it. And we've got a pretty good landing there. And we'll lift this until that CV axle looks at least a lot straighter than it is. Alrighty, so we now have a much wider gap here. Let's try it without the swivel first. Let's see if we can kind of jam it back in there. Got it. So I found this random metal bar out in the shed. I don't even know what it goes to. Probably is not going to stand up to the force, but we're going to give it a shot anyway. Yep. Here it comes. Now this top one, once you get it out, you're probably not going to be able to completely remove it. But as long as it's not threaded into the hub assembly, that's our primary concern. If we're not able to completely remove it from this gap here because of the axle, that's not the end of the world. See, I'm not going to... There we go. But if you have to leave it back inside here, that's okay, as long as it's not threaded into here. Now comes the really fun part, is there's a lot of rust and corrosion that builds up between the hub and bearing assembly here, which is iron/steel, and this. They're separated. They are no longer attached to each other by any means other than that rust or corrosion. Alright, the axle is loose. All three of the bolts are out. Spindle nuts off. Alright, but you can see it's still in there. So what you have to do is literally just beat the mortal daylights out of this until you get a crack. I'll tell you what might make life a little bit easier to see. Get a wire brush here. Preferably one that ain't rusty, but my toolbox leaked a little. You can even knock out your studs here if it makes life a little bit easier for you. Whacking it a time or two from this side. I think I just seen a crack open up between them. Right there. There's a glimmer of hope. Now once that starts, basically what you got to do is try your best to take this off evenly. So I'm going to drive a wedge into here until I see a little bit more movement, and I'm going to stop, and I'm going to try to get the other two corners going, because it's not press fit, but it is nearly an exact fit. And if you try to pull out one corner all at one time, there is a chance that you'll wedge it and make it even worse. much other than bend it. Oh man, here we go. We're getting there. You see that gap? See that gap? There's hope. More hammers. So we're not having a ton of luck getting the gap to spread open. So we've gotten a little bit of movement, but I'm not able to get a chisel in there. So I'm gonna take a torch here. It's just propane, and I'm gonna try to heat the knuckle here to try to hopefully get it to expand away from the hub and bearing assembly enough for some movement. I don't know. This is awful thick. So I don't know if I'll be able to heat it up enough, but I'm going to try it anyway. And try to heat it up, and then squirt some WD-40 in the bolt holes. I'm going to go ahead and heat this side. Torch isn't wanting to run at full bore, it's a little cold. I'm going to heat the knuckle, not the hub and bearing assembly, the knuckle behind it that it recesses into, because you want it to expand away from the hub and bearing. I'm going to try and heat this up a little bit more. Let's whack it a time or two, see what we can get. Oh, there's a gap widening. There she comes. Not quite ready to pull out, but it's coming. Let me check the other side. What's it look like? Oh, other side's in good shape. Maybe. Lord of mercy. It's coming. Alright, the railroad spike. A little bit wider end here. Try the railroad spike here. It's what fatter. At the top. I think we just got it. Bottom left corner. Oh man. There we go. And here is the bad hub and bearing assembly. Let me show you why it's bad. These two parts should have minimal play between them. That is not my gloves rubbing on that. That's a bad wheel bearing. So that's why it was making that grinding and wailing noise. Alrighty, so you can see it only slips back in there, you know, an inch or so. But it's all this corrosion that causes us the heartache. So, alright, so the old wheel bearing is out. So now what I'm going to do, I'm going to clean inside here real quickly with my wire brush, best I can anyway. You see that solid bead of nastiness right there? I'm trying to clean as much of that out as I can. Alrighty, so now that we've got this reasonably cleaned, I'm going to swap my leather gloves for some latex gloves here, nitrile, whatever, and we're going to grease this thing up. I have here a tub of Mobil 1 high temperature synthetic grease, and I'm just going to take my fingers with latex gloves on, and I'm going to just grease, put a healthy coat all around the inside of this. For lubrication, and since it's synthetic and high temperature, the idea is also that it'll last longer, and it'll also help keep moisture out of here and prevent this bad corrosion in the future. Whether or not it lasts 200,000 miles, who knows. I'm also going to grease the splines here on the end of the axle. Alright, and on this one, I'm going to grease a couple places. I'm going to grease inside the splines where the CV axle is going to go. So just take a finger, shove some back in here, and run it around in a circle so that it's got grease in there. I'm also going to grease around this surface back here, because that is the surface that's going to mate up, and this is the surface that was corroded on the old one. So I'm going to put a layer of grease on here, and not only will hopefully will this make it less prone to corrosion in the future, but this will also hopefully make it easier to install. We need to line up these holes with the bolts that we took out a while ago, the 3 triangular bolts, while also inserting the CV axle into here. So in order to make that job a little bit easier, I'm going to get back in the car and I'm going to turn the wheels back so that they're perpendicular to the axle. There it goes. We've got it in here enough that I'm going to pull it on back with the bolts that actually hold it in place. So that one's okay. So what we're doing here is we're actually using the bolts to pull the new part into place as evenly as we can. I did have to tap it a time or two here. You can see there's some dings on the new part there, but I did have to tap it a time or two to kind of get it straight so that the bolts would actually thread in and not cross-thread each other. But we're just going to go back and forth between these 3 bolts, tighten them a few turns each, and try to get it as even as we can. Alrighty, all 3 of them seem pretty tight. I'm going to make one more pass here. That one's pretty well done. So with that one. Alrighty, so you can see here that it is flush where it's supposed to be. It's squished out some grease. There's no visible gaps. The bolts, the tips of the bolts are protruding through the little holes just a little bit, so it's tightened on correctly. Alright, now what we do is we replace our axle nut. It does not appear to be tapered or shaped in any way, but you can see that it has a little ring on this side where the nut gouged into it before, so I'm going to try to replace it in the same way it came off. Put the washer on first, and then the nut, and then a breaker bar with our 29mm socket, and we just start tightening her. Alrighty, now as a general rule, this thing requires a lot of torque. I don't remember the exact rating for this vehicle, but generally speaking, if you can tighten it tighter with your hand, then it needs to go tighter. Generally speaking, these require somewhere between 150 and 200 foot-pounds of torque, generally speaking. So I figure there's no way I can put that much on here with my hand and a breaker bar. So I tighten it as tight as I physically can, and then step on it with my body weight a time or two, and that should call it good. Now even with all that said, there's a chance it could just be bound up on rust, so we're going to look in here. The washer is not free spinning, it is making good contact there. Since I have steered the wheel this way a little bit, let's go ahead and reinstall our brake caliper. Even if we want to re-tighten the axle nut later, if we want to double check it, we can do that with the caliper in place. Reinstall our brake rotor here.
I just wanted to point something out right here real quick. When you're installing your brake rotor, you might want to make sure that you absolutely do not get any grease on the braking surface of the rotor, but you may also want to apply a very light coat in the center where it actually contacts your hub so that it won't rust to it in the future.
Lower the caliper down and line it up with its bolt holes. And line up these holes and reinsert the bolts. First one started. Alrighty, let's go ahead and lower our jack so we're not trying to fight with it with the tire on, because the jack stand's going to hold us up high enough to get the wheel back on. Now, since these are new studs, I am going to go ahead and put just a dab of grease on the lug nuts, or on these studs, because you can use anti-seize. In fact, anti-seize would probably be better. But the end goal is I don't want these to seize up where it takes 100 pounds of force to break my lug nuts loose next oil change when I go to rotate my tires. There we go. Let's get them started so they're in position. Those are all hand tight. There we go. The jack stand is free. And now we take our tire tool and we actually tighten go back around one more time and check. And now we clean up the mess we've made here in the driveway and take it for a test drive. Oh, that's much better. We used to be able to hear that grinding whoop 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 type sound even out here on the blacktop when we're only doing 20 miles an hour. We're driven about 10 miles on the highway at highway speeds, and we want to check a couple things. We want to make sure that our lug nuts didn't loosen. That one did not. Because you never know, when you first put things together and then you drive on them, you put weight on it and actually go down the road a little bit, things will kind of settle and may loosen a little bit. So you just want to make sure that everything's still as tight as you want it to be. Alright, and then we're going to pop this little hubcap cover out of the center, grab our breaker bar and our 29mm socket here, and make sure that the spindle nut is still nice and tight. I have to tap it on there a little bit because it's an exact fit. It's on there. It's good. We're good to go. Alright, so that is how you replace the front wheel hub and bearing assembly on a 2006 Ford Taurus. If you guys have any comments, questions, concerns, or suggestions, please feel free to post them in the comments section below. And as always, this is Marcus out. Y'all have a good one.